even though we're going to talk about our overarching collaborative project.
Right.
So my name is Dr. Vicki Lynn Holmes. I'm a math professor in math education.
And I'm Jane Finn, and I'm in special ed.
I'm sorry, can you say that louder again?
Our names?
Yes, please.
My name is Dr. Vicki Lynn Holmes, and I'm in math education.
And I'm Dr. Jane Finn, and I'm the special ed wing of this.
Thank you.
No problem at all. And I'm glad actually that young lady said that. So if you have any questions, we do not mind you just yelling out and letting us know, and then we'll accommodate.
And it also lets us know how to project, because this room is a little different.
Yeah.
Right. So as I said, we did a collaborative effort with a lot of people, which Jane is going to talk about. But we're concentrating today on word problems, why we chose word problems for today. And as most of you know, just for a little background, the biggest thing is that word problem success is important in terms of our algebra. And all of us know that algebra is the gatekeeper for other math. So word problems is really important, and it's how we model the physical world around us, right? I mean, anything as little as, or as big as E equals MC squared, to as little as a perimeter, area, surface area, all of that.
0.1 small.
Yes, that's true. So, authentic and culturally relevant if we do our word problems correctly. The next one is test success. I don't know if you knew this, but during research we discovered that mastery of word problems was linked to criterion reference test success. So just getting your kids, basically, because there's so much wordy word problems about it. And then the next one is reasoning. It's highly correlated. 0.37 may not seem high, but in social sciences, that's high, right? We're so complex. So to explain anything about us is good. So highly correlated with results in computational skills, right? And algebraic reasoning. And then STEM. And that's what we're kind of interested in here, right? Heavily laced with word problems. And if they're already negatively thinking, I hate those things, then, they're going to STEM fields, science, technology, engineering, heaven forbid math, they won't go into. As a matter of fact, I was an English major and started teaching English, 17th century British lit. Before I went into math and got a doctorate in math, because I was thinking, math is over here, right? So we don't want our students having to do that. And then finally, math literacy, right? So we have not yet overcome this whole word problem hurdle. And that's why, out of all of the things, there's lots of different areas when we were doing our collaborations that students talked about, and teachers and educators, but word problems was a big one.
Because no one likes word problems.
Exactly.
Okay, so this is the teachers and the parents and the students pulling their hair out, right? Because how do I teach, or how do we do math for individuals with disabilities and students at risk? So it's not just those individuals with disabilities. And in order to get a diploma, we know what we have to do: the algebra, the geometry, maybe the algebra 2. And maybe can we get them into higher level math? How can we get that basis? So we're going to talk about today our survey that we did and what we did to collaborate to get teachers to understand how they can do and how can they best serve students who are at risk and have disabilities.
And then finally, what our approach to teaching word problems, how it changed, and what we did. So in 2010, in collaboration with Michigan Council Teachers of Math, we did this huge survey. And then in collaboration with the Ottawa Area School District, that's in Michigan, our school district in Michigan, we had different workshops called Teaching Algebra Concepts Through Technology, right? So it was TAC 2. So we had this big survey, and then we had cohorts where we talked to them. And we found out that word problems was a huge topic, right, that math educators wanted help. And they said they wanted help in these following ways. More planning time around actually thinking about the word problems themselves, how to teach it, right? More collaborating with other colleagues. Access to resources aligned with the Common Core state standards. Because, as you know, the Common Core has said they're really advocating using word problems and teaching them conceptually. So it's like all of a sudden, what does that mean? Like okay, you put those words out there and they sound good, but what does that mean? So what's the emphasis going to be on when we say conceptual understanding? Is it less algorithmic? How are the student expectations supposed to change, right? How does practice actually change? And then some people wanted to understand how the Common Core different from what we already had, right? So there are all of these different things. But over 50% of the educators didn't feel that their textbooks were very good at helping them to teach the word problems, or much that the Common Core was telling them that they had to do.
So that, as researchers, we always look at prior research, right? So we noticed that teachers said, hey, we're not equipped to teach these word problems. Our teacher prep didn't really focus on that.
True story.
There you go. Neither ignorance or tack a few problems at the end of the lesson. So they either ignore it or say, okay, let's put some things at the very end and we'll make it word problems. Give abbreviated explanations. Not too much practice, not too much follow-through. Okay, and overgeneralize the skills required to attack different word problems. So what we're really saying, one size does not fit all, even though that's what they might have been taught how to do. All right, so here's our idea. Vicki, Lynn, and I got together. Remember, I'm special ed, and she's math. And I said, you know what? How are we going to teach, and how can we give back to the field? How can we get our teacher prep people practice teaching students who are at risk and labeled with an IEP? And we want to, of course, get them out in the field, right? We don't want them to do it in front of us. We want to get them out in the field. So we said, okay, well, what's missing? So we collaborated with Kristen, who is in an area school, and that's her picture right there. And we said, let's figure out how we're going to teach math through different subject areas, like art, like kinesiology, like social studies.
Yeah. So all the lessons that we did, we figured, okay, these people don't really like math to start with, but they have an interest in other subjects. And usually the same people that like math like science. So we thought, we're not pairing math and science up. We're going to teach math through art, or math through physical education, or math, so like the art with how throwing a basketball into the hoop and different things like that. So everything was not math and science.
So for example, one group came up with how are we going to teach about the Revolutionary War, and how they shot their muskets. This is one way, this is a different angle, this is a different angle, and this is a different angle, and just teaching those things. So they're like, Revolutionary War, kind of like, that's interesting. How can we do that? So that's how they can grab the students' interest with that. All right, of course, we want to make sure that it is relevant and rigorous. So Kristen watched the students teach. So the students, the pre-service students, were one in special ed or more, one in math education. So we're teaming them up, so they need to learn how to team. They went in front of a classroom and they had to teach their lesson. Kristen, not only did they have to record themselves, Kristen had to evaluate them. So she's sitting there back and evaluating them, right? And then, of course, the professor gets to evaluate them too. So after their lesson, Kristen actually brought them out and started telling them, hey, this is what you did really well, this is what you need to improve on. Okay, so it was very powerful for our students, and also the Zealand students got to evaluate the teaching as well. So everyone has something to input with it.
Before we do the last one, we just wanted to show you like the teacher evaluation. Keep going.
I wish I could evaluate my teacher.
There you go. Because look at how you could do it over there. It says student survey.
And I don't mean my now teachers. My now teachers are nice and smart. But at my old school, the kids were incredibly nice to me, but the teachers were mean and not so smart.
Well, so you would have liked this because we wrote awesome and look at the stinky. They're awesome or stinky.
Yeah,
and
they were sneaky. They weren't very good at
so
what they did.
they had to read these and they said, okay, I'm going to say that they were great
No,
or they.
If my teachers saw what I thought about them when I was back in reading, they'd have killed me.
But
You
the
didn't give it to the
students,
teacher.
the students got to look at what this.
Oh, then everyone would agree.
Yeah.
Then everyone would agree. Nobody liked our teachers.
Okay, well, keep on going.
Reflection.
All right, so this is they did get graded for it. So remember, their students got to grade them. The teacher in the field got to grade them. The students got to look at how they did it, meaning they got to look at their video and reflect on it. And then, of course, Vicki, Lynn, and I got to look at it. Gave them the points because you know what? For some reason, you got to give them points in college.
That's right.
You got to give them a grade, right?
So after all of this, we collaborated with other mathematicians and in the state and out of the state, other special ed, and we ended up writing an algebra textbook, as a matter of fact. And the textbook is geared toward at-risk and special ed. And when I say that, we're going to talk in a moment about computational ease. You don't have to teach a huge concept with huge numbers, right? If you're trying to get the concept, you don't have to start with negative and positive numbers. You don't have to start with a lot of fractions. As you're teaching a concept, it can be very basic computation, so that's not what is getting in the way of actually teaching the lesson, right? So nothing past 11 times tables. All the answers, the students don't realize this at first, but the teacher can go around because all the answers are going to end up being whole numbers, even if they don't start that way. So you know if there's a lot of messy work at the table as you're walking around, someone has something wrong, right? I mean, it's just made to be at ease. For even the lecture part has closes, a fancy word for fill in the blank, right? So as the teacher is doing whatever lecture part, the student can fill in. Now, a lot of times in textbooks you have something similar, but what happens if you're absent, right? All the answers to the closes are in the back of the book, of the student's book. So if you're absent, you can fill it in. Even if you weren't absent and you didn't get anything, you can go back and look at it, right? So as long as it's completed, you're cool. But it's just a lot of things that will help in, but the reason we put it up here is for word problems, there's a chapter 3 that's dedicated to treating word problems as a skill. Word problems are a skill, and we're going to talk about how you classify different word problems and things, but right now it was piloted in Alabama, and if any of you guys are at schools that need piloting, because you get the textbook free, we just get the scores for your test scores. Talk to us afterwards. I had to put a plug in for that. So again, word problems, the bane of high school algebra students, especially, you know, at risk in special education, and causes. The poor reading comprehension skills, limited math vocabulary, and difficulty changing words to algebraic expressions.
What is that innovation?
Isn't that cute? Something I paid for.
It was like a guy holding a gigantic knife, pen, arrow thing.
No, it's a dart. And we want to hit the target.
You're right.
It's a
But
dart.
there's no such thing as a dart the size of
Oh,
your
be
entire body.
quiet. It's good. Okay, next slide.
It's scary. I don't want to get impaled by that.
So traditionally, word problems were not categorized by similar types. So our students don't know how to decode. They don't know what skill do I need for this type, what skill do I need. It's all just kind of thrown in there together, and most math teachers don't even think word problems have types into them. So that's just not the way they were taught to us or how to teach them. So it doesn't allow mastery into any one thing, right? It's unnecessarily cumbersome with the numbers. And so all of that hurts the reading comprehension. Too many words in there that you don't need, that aren't necessary. We're not trying to trick our students, right? We're trying to teach them skills. So just because you make it, hard, doesn't make it right or good, right? Pedagogically. Then understanding the syntax. We got to teach them how to do that. Now we've started some, but there are still people that don't know of means times. So every time you see of, it means times. Like there's different things, tricks of the trade that you teach your students, so at least as they're reading, they can automatically start translating, math into English, because math is a language, and it has rules, right? It has definitely rules. Students just don't normally see it. Next. So now I'm going to tell you the classifying, and you have this page already. So word problem, the first type. This is the first type and the easiest type. These are the kind that say 2 more than 3 times a number is equal to 30 minus that number, find the number, right? It's just those straightforward. It's straightforward because all the information needed to solve the problem is inside the word problem. So those are the simple, those are the ones you want to introduce to students first. And remember, we said skill. Think about playing tennis. When you play tennis, you don't learn backhand, forehand, all the different roles at one time. You learn one thing and you stick to it. The piano, you learn the whites. You don't go into the sharps and the flats. Like, you learn one thing at a time and you practice till you get that done, right? Practice is not a dirty word. We've kind of turned it into rote memorization. No, it's not. We need practice. And so you want to practice word problem number 1, these types, where all the information is in there. No other information is needed, and you stick with that. The second type of word problem are the ones that have some vocabulary, and you don't try to put 2 or 3 vocabulary words in there, just one at a time, right? Then you can move to 2. So, one complementary angle is 10 more than the other. Find the measure of these 2 angles. Complementary. You just have to know what that is, right? And then you can find it. So that's a little harder than the first one, but now you give them a lot of different, area, perimeter. You give them a lot of different word problems where they have one vocabulary word in it that they have to do. The last one, and this is what a lot of people do first, money. Do not give money word problems first. In money word problems, not only do you have to know the relationship between the nickels, the dimes, the pennies, the quarters, whatever, you have to be able to translate them from cents to dollars. And there's a lot going on with money. So, again, problem 1, it's more or less simply a translation of the algebraic expression. And remember, that's one of the things they had problems with. So you're going to inundate with them with just problem 1. Problem 2, you have 2 things to consider. Writing the expression, so 2 angles involve x, 1 angle, and x plus 10, right? And then you have to know the definition, complementary, to know that they add up to 90, right? So, or supplemental, whichever one, whatever vocabulary you're using. But you have to be able to know that. See that? And then the third one, with the money, there's a lot going on with the money, right? The expression has to take into account both number of coins. So n equals nickels, n plus 7 is the number of dimes, and the value of the coins, 0.05 times the nickel, right? Value of the nickel, and value of the dimes, 0.10 times. Now I like to have my kids multiply them out so that I get 5n plus 10, right? So they can stick with the whole numbers, especially as they're first learning. And then that will equal. Then the final step requires integrating the value of the coin, the number of coins, and the sum total. That's a lot for someone who doesn't know anything about word problems or is just learning. The other thing, think about it like this. They're not getting a bunch of word problem 1 types, a bunch of word problem 2 types, and then a bunch of word problem 3 types. They're getting them all mixed up. And you only give them maybe 5 word problems, and they're all different types. And you're expecting the student, you're assuming that the students can look at these problems, understand the approach for each one, right? And all the underlying assumptions on their own. And no skill works that way. I mean, some of us are innately good at tennis, innately good at piano, innately good at sports, right? And so something in us helps us to navigate that. But word problems doesn't really seem to be that way. We have to think about it as a skill, right? We have to think about it as a skill that the teacher has to break down, especially for at-risk and special education populations. But we found this is true for all populations, right? This isn't what do you call it?
Yep, or a strategy just for special ed.
Yeah, it's not at all.
I mean, good teaching with individuals with an IEP is good teaching.
It's good teaching. I'm going to tell you the biggest compliment I ever had. I taught public school, middle school and high school for like, hate to say it, 30 years before I went up into the college level. And when I was teaching at-risk classroom, about 30 students in the classroom, and we were going over some pre-algebra stuff. And no aid, because they give you one or they don't. Sometimes you get them, sometimes you don't. Right? Everybody in there. And the State Department people were coming in to kind of look at the school. We were kind of flagged. So they were looking at the school. And in the middle of the class, the lady said, "Oh, I'm sorry, we're in the wrong class. We wanted to see your at-risk people." I was like, thank you, Lord. My job is done, because they couldn't tell. I didn't dummy it down. We were learning things, right? But they were like, wow, you're doing just regular concepts. Yes. That our job is to, we were just talking about this in the car. What's the word? Go from one to the other?
Scaffolding.
Scaffold. Our job is to scaffold, right? Our job is to scaffold. So, what do we do then? We taught word problems as a skill, right? Next. We categorize them by content type. We categorize them by level of difficulty.
That's smart.
Yes, it is. Practice, practice, practice. One skill at a time. And then remove the computational difficulty, right? So that students can begin to recognize the patterns. You want them to be able to do it enough that they look at this and say, oh, I know how to attack this. Oh, it's not gibberish. Oh, I know what to do. So you have to give them enough, right, the repetition, so that they can look at it and say, okay, I know what to do. And you add, then in these same word problems, you add negative and positive numbers. You add some fractions in them. But you start with just whole numbers. And this is from middle school to 12th grade to college. I teach stats now in college, and I do the same type of thing. I start them with all my concepts without computational complexity, because they don't need it. And this is college level. Then we throw it in there, but then they're okay, right? Then they're okay. They're all saying, why didn't someone teach me this before? They were teaching it to you, they just taught it over your head.
They did a good job scaffolding.
They did not do a good job. So now look at this. A sweater costs $48.81. A pair of designer jeans costs $76.34. You have $876.05 and want to buy an equal number of sweaters and jeans. How many combinations can you purchase? They were trying to get you to understand about equal number. Right? How solving a problem equal number. You look at that, and most of the students are just going to sit there. They're going to look at the numbers. The numbers, computational, keep it simple, stupid, kiss. They're going to look at the numbers, and they're just going to be like, oh, what do I do, right? Click. But if I say a Coke costs $2, a hot dog with all the chilies costs $3, You have $35, I want to buy an equal number of Coke and hot dogs. How many combinations can you purchase? They'll start trying. I mean, I didn't do anything else here, right?
You
But
just
make
got
it
something
simple.
they were interested in.
Right. Well, that
And
too.
smaller.
I love hot dogs. but
Everybody loves
but I love jeans and sweaters. So. But anyway, so you're looking at this, and then you're teaching that skill. And you don't teach the hardest way first. You allow them talk about it. How would you talk about it in groups? Talk about it in pairs. How would you attack this? And you don't do like I've heard some teachers do, because sometimes the student teachers will look at them, and one answer and one way is the only way. That's not true. So click. So some say Coke is $2, a hot dog is $3. We want equal amounts. Okay, so both of these together is going to be 5. How many pairs do I have? Because they're thinking like this, and I get it. Great. I have no problem with that. That's not the way I was wanting them to do it, but in the class one time, someone did it like this. I said, fine, that's right. Right? That's what you would have done?
Yeah.
Next one. This is what the book had, which is what I was thinking they were going to get, right? X is now the number of items. It's not hot dog or Coke. It's the number of items, right? And each can be bought, must be bought in the same number. That's the equal amounts. So I have 2x plus 3x. Now items equal 35, and I get the same thing. It didn't matter that they didn't come at it the way that the book and I had thought they were going to come at it. It did not matter. Are they thinking it through? And if they don't, that's what you say, oh wow, I have a chance to correctable moment, teachable moment. I have a chance to start where they are and bring it up. Well, this was almost okay. What could they have done differently? They almost have it, right? And then you go. But don't say, oh, that's good when it's not good. I had 2 teachers in college, in my undergrad. I went to college with William and Mary. One thought women and people of color should not be in college. This is late 70s, early 80s. Shouldn't be in college. Okay? And he gave me a haha. In those days it wouldn't matter. C, I worked hard for him and he gave me a C+++. Because he refused to give a black person an A or B, but he knew there was something different. But, and the college let him do that. It was on my transcript for a long time. But the point is, I worked my butt off for that one. My history teacher, close his ears, crapola that I put on in the blue book. Oh, excellent, good job, good job. So I stopped working for her. I got my A. Now, whose grade was I proud of? The C+++, right? I got that. I stopped putting, I hardly even read the book anymore. I was like, oh, anything I throw out, she's gonna say, oh, good job, good job. Yeah, don't do that to your students, okay? They know. They can cut through. Oh, we give them E because we don't want to hurt their psyche. They know they fail, okay? Let them, give them the respect, right? To let them know, no, you got it right, but you were thinking. I applaud thinking. Let me show you, right? That's so much better, right? That's so much better. All right, so what are we saying? 1, we have what's called predefined. Everything is in the word problem. 2, we have, 2 and 3 are both not defined. Everything is not in the word problems, but sometimes it's simple vocabulary, and then this is 2B plus, because this is harder when you have a more difficult relationship, right? So that's what you're going to be thinking about when you're looking at word problems. So again, when you're looking at this side, the predefined, click. One variable is defined in terms of another, right? The students won't think about it this way. One variable is defined in terms of another, but math, we know that's what is happening. One variable is defined in terms of the other. And these are number equality, but also consecutive numbers fall into this. So number equality is what we already just said. 12 less than 5 times a number is 4 more than 3 times the number. Find the number. Right? That's that equality. Next, did it freeze? And then the 3 consecutive numbers, right? whether they're, give me 3 consecutive numbers, 3, 4, 5, or evens or odds, right? Consecutive x plus 1, x plus 2, right? If they're evens or odds, same thing, right? Because it's going to be 2. You just start with the odd or start with the even, and then you'll have them. Some people, when they do consecutive numbers, they'll say x minus 1, x plus 1. Don't start them off there, because you're automatically going to get into negatives, right? So why do that when you can just do it this way to begin with? It's not like you don't go back to it. You just keep it simple. KISS, right? Just keep it simple to start off with, right? And so another sum. This is the sum of 3 consecutive numbers. Okay, and then on this side, right, we have the ones, well, we won't, don't go back, I'll just say it. These are the ones that I told you about. You have to get some vocabulary or it's harder. So again, perimeter, right? The perimeter is 54. They have to know what perimeter is, right? 2 times the length plus 2 times the width, or however you wanted to define it. Next one. So what I would do with them, once I've gotten them with their word problem, I have them tell me what the relationship is, tell me what the formula is, tell me what the answer is. And they got to the point where they could tell me, oh, wait a minute, you mixed one in here. Or wait a minute, this is level 1, this is level 2. But that was great, because if they could understand which level of word problem is, they knew which skill is needed to attack, right? If they knew, they can look at it and say, oh, everything's in here. If they look at it and say, oh, I don't know what this word is, they have to underline it or highlight it, right? And that's the word that they have to look up if they don't already know it. That's an easy way to do it. You're looking at what word don't you have a clue on. Sometimes they're surprised because it might be dividend because someone used that instead of, right? Then you just tell them, right? You're like, oh yeah, that's good that you caught that. You guys, we want to use good vocabulary in math, so you just play it off. And then you go ahead and do the next thing. And then the last one again is the money, right? The last one again is the money. And this one is peppermint patties and jawbreakers. And again, even throughout the textbook that we wrote, we tried to find things. He said that, I don't know if he said that jokingly or not, but we did try to keep everything interesting, like something that middle schoolers and high schoolers are actually interested in, right? We didn't just, and again, nothing science, other topics, right? Other topics as you're going through. Summary, so you know what we did for our skill set. So I have, okay.
Oh, no, I don't want
Oh, no, you don't have to actually do the word problem. You're like, oh no, I don't want to do these word problems. I wanted you to see. I wanted you to see with these word problems. Now, this is part of the chapter. In the chapter, they have lots. The chapter starts with chapter 3. Starts with a lot of word problems of the one variety. Then the 2 variety. Then the 3 variety. And then at the end, you mix them up. And even at the end, when you mix them up, on the quiz, the first quiz, we still kept them in the same, kind of the same order. Do you see that? Later, for the test, later on, we gave 3 quizzes and then a test. The first quiz, you're scaffolding the same way with your quizzes as you do with how you teach. And you guys, there's no bait and switch allowed. If you teach one way, you have to test the same way, right? If you never teach with any multiple choice, don't put multiple choice on your test. So if you want to put multiple choice in your test, you got to include it in your teaching, right? No bait and switch, right? Again, we're not trying to fool with kids. We just want to see if they understood the concept we were teaching them, right? So we scaffold the quizzes. There's 3 quizzes, and we scaffold the quizzes the same way. One, they're all there, but they're in order. Then the second one gets mixed around more, right? And the third one is all over the place, right? But that's the way we do it. The first one, everyone has to take. The second one, where it's mixed all up, if they do well, I don't have to give the third one. I can just move on. But if they don't do well, I have that third one. So all of the chapters do that so that you have a choice. Because remember, we're not teaching to the classroom, we're teaching to the student. So sometimes they'll go faster, sometimes they won't go as fast. Even though I know we're getting to the place again, we were already here, we're back to it where they want everyone who's teaching the same thing to be on the same page. And I can't believe that's coming back around again, but that's not this lesson. So you see how it works? So also on the quizzes and the tests, after you've added in the negative and the positive numbers and the fractions and the decimals in class, then you're free to put them on the test. If you have not put them in the class yet, then you can't put them on the test.
Yeah, well, that's what my teachers do anyway, so.
Shame, shame. All right, so remember,
Or my
Really
teachers
quick,
used to do anyway.
anybody
It's
have
still-
extra handouts? We are low on this area.
here, do you want this one?
Thank you.
I didn't expect so many people, but thank you for coming. It's because
That makes everyone want to practice.
words and word problems. So again, practice, practice, practice. That's how they look individually. Practice, practice, practice. And then when you do them all together, and you guys have one of those so that you can see it. Okay. Do you have any questions for us?
No.
No. Yes.
Hi there. So I'm a theater teacher for students with autism, my students specifically, and I was really interested when you mentioned a multi-disciplinary approach to teaching math. I was wondering if you could talk a little bit more about that, because I'm always looking for ways to support other subjects, and math is one where I find it difficult to support.
I think because I started off English, as I said, right? And so I already had a predisposition to, I teach math in the English way. In English, you have stories from a beginning, a middle, and an end, right? You have nothing siloed. So I don't teach siloed, where every chapter kind of stands alone on its own. It's like, well, why are we learning this now? Because we learned this before, like everything's together. But when you do that, you start thinking about other disciplines. And almost anything, math is a language, math is a tool. So it's a tool for something. So almost anything, whether it's music, you know, and you want to talk about the scales. If dance, you can talk about movement. You can talk about speed. You can talk about all kind of things based on whatever the subject is, because math is just modeling the real world. So almost any example, can you give some?
Yeah, and you might want to give your book. You know,
Oh,
that's what
yes!
this is doing. And we actually made our students also think of, remember for pre-service teachers, also think of, you're going to teach this algebra concept. Here's your concept. How are you going to do it differently? You can't, you have to do it through different things. So maybe you would be one that would want this, and then you could just take that with you and get all these ideas. Yeah.
We looked at art, like in the book, there's something with art, there's, what are we looking at with art? Oh, symmetry, I think we were looking at symmetry. I can't remember now, I know, we looked at decoding rings and decoding stuff for bases.
There's a whole bunch
We
of
looked
things
at
that we can't
this
remember.
golf game for negative and positive numbers, because if you're below par or whatever. We looked at, I can't remember all of them, but your imagination will soar. I mean, when you start thinking about it, you say, oh, I can figure out things to do to help it. There was a lot of sports, because sports is so easy. There's a lot of sports things.
Sports are not easy, they're a pain in the butt.
To use
Or they could be a pain. Either way.
Even when they came up with that different angle, and they brought in the Revolutionary War.
Yeah.
This is what we want you to do, and that's something that's interesting to them, and then you can start talking about different, just weave it all.
And almost any topic in math, you can have an example, some other example to use to put it through. At the end of the chapters, we have explorations. And the explorations are simply like a mini project, you know, like project-based learning, a mini project that will use whatever skills were taught in that chapter. The other thing that we did was in the chapters, a lot of times you need knowledge, pre-knowledge of how to do something. Even canceling. I mean, something as simple as canceling. Because canceling gets used so much in algebra, especially regular canceling of numbers, but then it goes to, you gotta remember, oh yeah, I have to cancel the unit, you know, or I have to cancel, right, inches or whatever it is, right? So what we did was, for any topic that's taught, all the background knowledge that's needed in there, there's a section right beforehand that teaches that particular thing, especially for beginner teachers. Because beginner teachers, you have so much to get together. It's like, how, because we're doing this for our pre-service teachers and things, how are they going to even think about all the information that you would really need to be able to do this? But it just simplifies it so they can do the pre-thing and then teach them the algebra. Do the next pre-thing that goes with that, do the algebra. So that's why it's set up for at-risk and special ed. But we're finding that everybody, yeah, it's good, which is best practices. I think I became a better teacher because of the special ed friends that I had, learning from them. And as I learned from them, more white space, bigger numbers, make it simple. As I learned things from them, I started doing it for everybody and saw such a great increase. So it's just good.
We only have a few more minutes, but I saw another hand.
So maybe I missed information, but what were those students that in your group, they were in special education and those who are at risk? So do they have a disability or?
At risk do not have a disability, they don't have an IEP. They're just maybe background makes them at risk for dropping out of school. So in Michigan, we call them at-risk students.
The special ed ones, though, do.
They have an IEP.
Yeah.
So what were those hands-on activities? Because it's mentioned here, you used.
That's the ones,
Students.
the explorations that I was talking about at the end of the chapters, they're responsible for each of the teaching ones. Each year we did different ones, like geometry or algebra or whatever. But the students created those explorations. They had to be hands-on things, with the topic being math and whatever the interdisciplinary topic was. And the interdisciplinary topic couldn't be an add-on. It had to be, you're actually learning this. Oh, I remember one, like photography. So in photography, they, 2/3 rule. Anyone a photographer in here? I can't think of the name of the rule. What rule is it?
Rule of thirds.
Rule of thirds, right? So you don't want it centered, like you have to put it, so the thing that I'm looking at her, so she's my object. She's gonna be in a third, and then the other part of the picture is here, or however, I don't remember exactly, but that's what they were looking at, the rule of thirds. And so in the math, they had to divide up the papers in thirds and look at the different things and figure out how to do it. So almost any topic, but it had to be something that they had to actually look for the standards in art, or look for the standards in the other thing, so that they're both, right? It's not an add-on. We're showing how math is used in this, for real, you know, not for fake.
All right, I think we need to let you guys go. But thank you so much.
Thank you so much.